Hello viewers, welcome to my channel Math Made Easy with PDY. It's a great privilege to come once again to your way to take you through some revision on some math topics. In today's lesson, we are going to actually revise on the topic SURDS. So by the end of this revision, you should be able to simplify SURDS. You should be able to rationalize SURDS with respect to monomial and binomial denominators. Come along, let's go through some work examples. Now, as usual, we have some WASSCE questions that we are going to use as our work example. So the first work example we are going to consider is evaluate 4 minus root of 2 all on root of 2. In this case, in order to simplify this question, we need to get rid of the radical sign at the denominator. Hence, if you analyze it carefully, you realize that it's a monomial set at the denominator. Hence, in order to rationalizing monomial sets, you just simply need to multiply the surd by itself. And whatever you do to the denominator, you equally do same operation on the numerator. So having our expression as 4 minus root of 2 divided by root of 2, when we are rationalizing, we multiply the whole expression by root of 2 divided by root of 2. This will be leading us to 4 root of 2 minus, when root 2 multiplies negative root 2, we get actually the value 2. Divided by root 2 multiplying root 2, we also obtain 2. Now, if you look at it carefully, you realize that we can split the information into two fractions. So we have 4 root 2 on 2 minus 2 on 2. So when we simplify, we end up getting 2 goes into 4. That is 2 root of 2 minus 1. Hence, the solution for the first example is possible answer B. Going to the next example, in terms of simplifying such a question, it still needs for us to rationalize, but we need to simplify it so that when we rationalize, it will be easier to work on. So having root of 72 on root of 48 minus root of 3. When we simplify root of 72, we obtain an answer of 6 root 2, all divided by root of 48 also gives us an answer of 4 root 3. Then we have minus root of 3. So when we go further, you realize that the denominator has 2 like surds. Therefore, 2 like surds can be simplified. Therefore, we are having 6 root of 2. Now 4 root 3 minus 1 root 3 will give us an answer of 3 root 3. Now we can actually reduce the coefficient of the two surds. The coefficient of 3 can go into the coefficient of root 2, and that will give us an answer of 2 root 2 all on root 3. Then at this moment, we need to rationalize. So rationalizing, we can multiply, because it's now a monomial set, then we have to multiply both the numerator and the denominator by the monomial set. So we have root of 3 multiplying the numerator, which is 2 root 2, all on root of 3, also multiplying the denominator. And that is going to give us 2 root of 6. 2 will multiply the coefficient of root 3, which is 1. So 2 times 2 is 2. And root 2 multiplying root 3 will give us root 6. Dividing root 3 multiplying root 3 will give us the value of 3. So in simple terms, our final simplification for this question, root of 72 all on root of 48 minus root of 3 gives us the answer 2 root of 6 all over 3, which is the possible answer A. Now to the next question, we are to evaluate 2 root of 28 minus 3 root of 50 plus root of 72. So having the question as 2 root 28 minus 3 root of 50 plus root of 72. Then we need to simplify the 28, the root of 50, as well as the root of 72. So root of 28 actually gives us an answer of 2 root 7. So we already have a coefficient of 2. So we are going to have 2 times 2 or root of 7. Then minus, this is also going to give us 5 root of 2. So that is going to give us 3 times 5 root of 2 plus root of 72 also can be simplified to get an answer of 6 root of 2. So we have 6 root of 2. Now, going further, we have this as 4 root of 7 minus 15 root of 2, then plus 6 root of 2. You realize that we have some like surds there. Therefore, like surds can be added or subtracted. Unlike surds cannot be added. Therefore, we maintain the 4 root of 7. And then negative 15 plus 6 will give us an answer of negative 9. So we have negative 9 root of 2. So simplifying the question, we have 4 root 7 minus 9 root of 2, which is possible answer B. So moving on to the next example, we have simplify 8 divided by root of 18. So 8 divided by root of 18, then we need to rationalize, but we have to simplify the root of 18. So we can maintain our 8 divided by root of 18. When we simplify that, we are going to get an answer of 3 root of 2. 3 root of 2. Then when we rationalize, we are going to multiply the numerator by root of 2 because the monomial set, and the denominator also by root of 2. And hence 8 times root 2 will give us an answer of 8 root 2. And then 3 root 2 multiplying root 2 times root 2 will give us an answer of 2. Multiplying 3, giving us a final answer of 6. Then we can reduce the coefficient of 8, the coefficient of root 2, which is 8, and the denominator, which is 6. 2 goes into 8 4 times, and then goes into 6 3 times. So we end up getting 4 on 3 all times root of 2, which is the possible answer B. Then we move on to another example whereby we have given that root 3 plus root 5 all on root 5 is equal to x plus y root of 15. So find the value of x plus y. In order to solve for the value of x plus y, we first need to find the value for x itself and y on its own. Therefore, there is a need for us to simplify the left-hand side. So taking the left-hand side into consideration, which is root of 3 plus root of 5 all on root of 5, we need to rationalize. So rationalizing, checking the denominator, it's it's a monomial set. Therefore, rationalizing monomial set, you need to multiply both the numerator and the denominator by that set. So we are going to multiply the numerator by root of 5 and the denominator also by root of 5. When we simplify, root of 5 multiplying root 3 will give me root of 15. And then root of 5 multiplying root 5 will give us an answer of 5. Divided by root 5 multiplying root 5 giving us also 5. Now, because our solution we are looking out for is two separate terms, then there is a need for us to split our root of 15 plus 5 all over 5 into two separate terms. So we'll have it as root of 15 divided by 5 plus 5 on 5. And this is the same as 1 over 5 root of 15 plus 1. But remember, we are told that our answer must be in the form x plus y root of 15. Then there is a need for us to rearrange the position of the terms we have as our answer. So that is going to give us 1 plus 1 on 5 root of 15. So when we compare the two statements, then it means x must be equal to 1 and then y should be equal to 1 on 5. Therefore, looking out for the solution of x plus y, it must be 1 plus 1 on 5, which gives us an answer of one whole number, 1 on 5, which is possible answer B. Now, going further, other examples includes what we have here, which is simplify root of 128 all divided by root of 32 minus 2 root of 2. Now, if you consider this question carefully, you realize that those sets or the radicands under the radical sign, they are very huge. Some of them are huge. So there is a need for us to simplify them before we can go ahead and rationalize where necessary. So having root of 128 all divided by root of 32 minus 2 root 2. When we look out for root of 128, when we simplify that, that gives us an answer of 8 root 2 divided by root of 32 also gives an answer of 4 root 2. Then minus 2 root 2. Going further, it means we are going to have 8 root 2 maintained, and because the denominator has like sets, then it means we can simplify them. Like sets for the fact that they have the same radicand, so we can go ahead and subtract. So that is giving us 2 root of 2. Now, in this case, you realize that root 2 and root 2 is a common factor for both sets. Therefore, it can be done away with. It can be done away with. And hence, 2 will go into 8, that is 4 times. So the solution for this question is possible answer 4, which is D. Going further, having 6 divided by root of 24 minus root of 6, we still have 6 all on root of 24. When we simplify it, we get an answer of 2 root 6. So we have 2 root of 6 here minus root of 6. Therefore, we have 6 on 2 root 6 minus root 6 gives us an answer of root of 6. Then at this stage, we need to rationalize. So since we have a monomial set, then we need to multiply both the numerator and the denominator by the set at the denominator, so which is root of 6 all on root of 6. Then that will be giving us 6 root of 6 all on 6. But the coefficient of root 6, which is 6, can go into the denominator 6, and that will give us an answer of root 6 left. So when you simplify 6 all on root of 24 minus root 6, you get an answer of root 6, which is possible answer D. Going further, we have more other examples like this. We are to simplify root of 3 all on root of 3 minus 1 plus root of 3 all on root of 3 plus 1. Per this question, having our root 3 all on root of 3 minus 1 plus root of 3 all on root of 3 plus 1, we need to find the LCM. Finding the LCM, we have one factor as root 3 minus 1, multiplying the other factor, which is also root 3 plus. And in this case, root 3 minus 1 will go into the LCM root 3 plus 1 times. So that will multiply the numerator. So we have root 3 all multiplying root 3 plus 1. Then we have our addition sign. Then root 3 plus 1 will go also into the denominator root 3 minus 1 times. And that will also multiply the numerator. So that will be given as root 3 multiplying root 3 minus 1. So in this case, we expand and simplify the numerator. That will be given as root 3 times root 3, which is 3, plus root 3, because root 3 times 1 is root 3. Then we also have plus root 3 times root 3 giving us another 3. Then root 3 times negative 1 will give us minus root of 3. All divided by simplifying the denominator, you realize that they are the same factor multiplying, but it has just the difference in the operational signs there. So we say that root 3 minus 1 has the conjugate to be root 3 plus 1. Therefore, you can use the idea of difference of two squares to simplify it. So that is going to give us root of 3 all squared minus 1 all squared. Simplifying the numerator, we are going to obtain 3 plus 3 because they are the like terms there. So 3 plus 3 gives us 6. Then root 3 minus root 3 will give us 0. So we are left with only 6 at the numerator. And then considering the denominator, root 3 all squared will give us an answer of 3 minus 1. So we have 6 over 2, which is a final answer of 3. So when you simplify this question here, the answer is 3. Now going to the next example, which is root 5 minus root 2, all divided by root 5 plus root 2. Is written in the form a plus b root 10. Find the value of a plus b squared. So it follows the same pattern, having root of 5 minus root 2 divided by root of 5 plus root 2. Now, before we can simplify it and leave the answer in the form a plus b root 10, we need to rationalize the denominator. So when you are rationalizing the denominator and you observe that the denominator is a binomial surd, then you need to actually rationalize by multiplying it by its conjugate. When I mean the conjugate of the binomial surd, it simply refers to multiplying the factor there by itself, but you just simply change the operational sign. And when you are rationalizing, you actually have to operate on both the numerator and the denominator with the same factor. So when we rationalize this root 5 plus root 2, we need to multiply the numerator by the conjugate of it, which is root 5 minus root of 2. And we do the same for the denominator. So we have root of 5 minus root of 2. So we are multiplying two binomial sets at the numerator, which is going to give us 5 root 5 multiplying root of 5 minus root of 2. Then we have minus root 2 also multiplying root 5 minus root of 2. And all will be dividing Looking at the denominator, something should come into your mind. It's the same factor but change in operational sign. One is positive, one is negative. So therefore, the idea of difference of two squares can be applied there. So we have root of 5 all squared minus root of 2 all squared. Then continue with the numerator. Root 5 times root 5 will give us an answer of 5. Then root 5 times negative root 2 will give us negative root 10. And negative root 2 multiplying root 5 will also give us negative root of 10. Then negative root 2 multiplying negative root 2 will give us positive of the number 2. Divided by, simplifying the denominator, we have 5 minus 2. Now there are some like terms at the numerator, which is giving us 5 plus 2, which is 7. Then minus root 10 minus root 10 will give us negative 2 root of 10, all divided by 5 minus 2, which is an answer of 3. So in order to leave the answer in the form a plus b root of 10, then we need to split this into two separate fractions, and that will give us 7 on 3 minus 2 on 3 root of 10. Then we can go further to answer our question, meaning our a value is equal to 7 on 3, and then our b value is equal to negative 2 on 3. Therefore, finding a plus b all squared, we have 7 on 3 plus negative 2 on 3 all squared. That will give us 7 on 3 plus 4 on 9. So when you add 7 on 3 plus 4 on 9, what are we getting? LCM is actually 9. 3 goes into 9 3 times 7, 3, 7, 21. And then 9 goes into itself 1 times 4, so we have 4. So finally we are getting 25 on 9. So 25 on 9 is the solution for the question here. So you bear with me that we've gone through a lot of work examples. This is our last example here, for which we are to rationalize. So in the same way, you are to simplify. When you are rationalizing 1 on root of 2 plus 1, what comes into mind? You have to check the denominator. Is it monomial surd or a binomial surd? With this question, we have it as a binomial surd. So how do we rationalize binomial surds? You simply have to multiply the denominator by the conjugate of it. And how do you multiply it by the conjugate? Or how do you determine the conjugate? Determining the conjugate is simply changing the operational sign there, and therefore you get the conjugate of the binomial surd. So what do you think? Your guess should be right. The conjugate of root 2 plus 1 must be root 2 minus 1. So we multiply both the numerator and the denominator by root 2 minus 1. And we do same for the denominator, which is root 2 minus 1. And simplifying the numerator, 1 times the factor root 2 minus 1 will give us root of 2 minus 1. Simplifying the denominator, what else comes into mind? The same factors but different operational signs. So difference of two squares should come into memory. So we have it as root of 2 all squared minus 1 all squared. And therefore we have root of 2 minus 1 repeating itself because you cannot add or subtract. Divided by, simplifying the denominator, we'll get 2 minus 1, giving us root 2 minus 1 all over 1, which is the same as root 2 minus 1. And that is possible answer C. Thanks so much for joining this revision section, and I'm so glad to come your way each day with new ideas. Please subscribe to my channel and kindly hit on the notification bell at all times. Whenever new videos are posted, you'll be the first to be notified. Please, let's reach out to all people who find math to be difficult. Thanks so much and have a nice day. God bless you.